really exciting to see many of our students and also guests here. I'm Haibo Wang. This is Dr. Hui Yang. I'm from Tsinghua. Hui Yang is from Penn State. So we have many email correspondence. So finally, great to see you and put face in the face with names. This session is kind of special, calling student introduction and interaction, and also student best paper competition. So it feels really great with the posters surrounding us, right? The background is actually 2 years ago, Professor Jian Xi sitting here, and he proposed the idea of organizing such kind of session. So we did this last year, but the problem with last year is that after session is too short, so students have no time to interact. So this year, after the session, we have lunch prepared outside. So the invited students and also guests feel free to enjoy lunch. So but still stay here, can have more time to interact, talk to each other. Also, we greatly appreciate our sponsors. So the first time we tried to reach out to find sponsors, Georgia Tech, Hong Kong University of Science and Technology, IBM, University of Kansas, Penn State, Tsinghua University, Northwestern University, and also University of Michigan. So their sponsorship have made this session possible, and also our idea about lunch finally realized we can enjoy lunch after this. We have two invited guests, Professor Jian Xi from Georgia Tech, and also Professor Thomas Das from University of South Florida. So in the following, we have around nearly 20 presentations, cost 1 hour. Then the rest 30 minutes we'll ask the two professors or senior members join us to answer any questions you may have. So we have invited guests. These 8 judges, they will help us to evaluate the posters and finally select one winner. I think next year we can select more because since we have so many posters. Really, I see students have spent a lot of time on preparing their posters. And beautiful and also rich content we see. They have done a lot of work. So I have 17 presentations and 9 posters, supposed to be 9 posters. Those are the names of posters. So next we'll start the presentation. So the first one, Marcelo Bacher.
Actually, it's Bacher in Argentina, but Bacher around the world.
Thank
you. This is which one?
Yeah, this.
Okay, thank you. Good morning to everybody. Really happy to be here. From the age average and the older as a PhD student. My name is Marcelo Bacher. I'm 40 years old from Argentina originally, where I study electrical engineering. I graduated in 2001 from the Technical University of Buenos Aires. I moved to Germany to do a Master of Science in Information Technology. I finished there in image processing, a little slightly different from my backgrounds in electrical engineering, and then I jumped into the industry in Germany as a research and developer engineer in the automotive industry, where I developed algorithms and systems for the cars. And in 2011, I decided to improve my skills and broaden more my knowledge and started a PhD program at the Tel Aviv University in Israel. And what I would like to achieve as after my PhD is to become an esteemed researcher in a multidisciplinary areas. And the idea is to cope with problems and necessities arising from students, also from the industry, to cope with really complex systems that it's not only to build a solution through statistics or maybe machine learning or electrical engineering alone. So the idea is, to find a path or try, because every column is really wide, but find a path to cope with these problems and to take tools and improve existent algorithms and also theory to bring solution and to close these gaps in the several industrial requirements also to the students. So I work for helping I close where I actually make my research is given some system, we collect data, we have to assume statistical issues about the data. We would like to buy, to to build a model. In this case, try to find it as a no parametric model with an application, a specific multivariate process control in the semiconductor industry, reducing the dimensionality through information theory measurements, statistical learning to find and classify kind of progress that we have. And of course, we have to deal with the optimization because at the end, we would like to improve the error detecting new problems that arise in this complex industry. So that's it.
Okay.
Thank you.
All right. I'm very glad to be here. I'm Jianguo. You can call me Jay. And this is my second year for my PhD degree. And I'm from Western New England University, and my wider job in me, doctoral degree. And recently I'm studying the reliability thing. And my dissertation will cover the lithium-ion battery capacity fitting prognostic. And this is the battery I'm studying, and this is the chamber oven, and that's the test station. And by a chance, I bring one battery here. The Tesla part is using 6,831 of these things. So I got a paper on general hot sauce. If you're interested, you can go there and find out what the idea is. If you have any suggestions, just email me or just call me. And right now, I'm writing a proposal for the used battery energy storage system. It's kind of interesting. And by the way, I'm teaching undergrad's probability and statistics and the TA. We can talk about that more. All right, so hope you guys have a very good time here and enjoy the conference. Thank you.
Next, Chen Guishao. Sorry, Stella is not here.
Good morning, everyone. My name is Chen Guishao. I'm a PhD candidate in the Department of Mechanical Engineering at the University of Michigan. Actually, I'm defending in about 1 month. Working finish. My dissertation topic is database based on timer modeling for surface variation monitoring. And my research advisors are Professor Jake Hu and Professor Judy Chu. Along with my PhD study, I also obtained 2 masters. One in statistics and the other one in operational engineering. Prior coming to the States, I completed my study of bachelor degree in automation. So as you see, I have broad backgrounds in different areas, so that's also true for my research. So during my PhD study, I have mainly focused on 2 topics: manufacturing capacity control and spatial temporal modeling. And both topics, all the programs, papers that are oriented in real manufacturing programs. So specifically for manufacturing price control, first I have worked on online quality monitoring for battery type joining of catapult. The project was sponsored by DOE and General Motors. We designed a novel monitoring system and implemented in a GM plant, and it's running successfully and reduced the collective cost a lot for General Motors. Secondly, I want to extend my research to process control of 2D image data, especially for spatial temporal data. For example, in the pre-crystal reliability process, we use X-rays to monitor and characterize the material flow during the process. So it's a very fast process, but we can collect high volume data. And also we can collect heat maps. We can collect heat maps from this process. So all of this data fall into the category of spatial temporal processes. However, there's a lack of methodologies for monitoring such data. So that's my immediate future research. So the second topic is about spatial temporal modeling. So actually this is somehow linked to the monitoring of spatial temporal processes. So in this topic, there are several applications. First is the tooling calculation surface processes of artificial welding of lithium-ion batteries. The second application, I just mentioned, is the built-in structure aggregation process. And also we will consider the high precision machining for image surfaces because the two degrades over time, right? So it's a time variant surface. Also it can fall into spatial temporal processes. So I have done several topics. Firstly, dynamic sampling design to optimize the locations of the environment to improve the efficiency of the environment. Secondly, structural modeling by incorporating engineering model with multi-task menu. Actually, I have presentation work in the poster over there. Thirdly, I want to extend my research to manufacturing process characterization using big data, including both spatial temporal data and also other implant information to pursue a newer, novel data fusion approach. Okay, as I mentioned, I have some background in automation. So in the future, I want to extend my research in another direction, which is to combine manufacturing programs and automatic control techniques for manufacturing system driven automation. By the way, I'm on for back this year. Thank you very much.
Yangji is at the University of Michigan. More details in the brochure, so we refer to the brochure. Morning, everyone. My name is Xiaolei Fa. I'm a second-year PhD student from Georgia Tech. My advisors are Professor Nagi Gabriel and Professor Cameron Penford. My research mainly focuses on algorithm modeling and real-time minimum useful life prediction using the high-dimensional algorithm signals. Some research I have been doing, one of them is to build a prognostic model for missing data applications. In reality, most of the existing prognostic models assume that the degree signals are observed continuously over time. But more realistic case is that the signals are observed discontinuously, like the figure B here. The signals are observed at some random time steps. If you can see here, the signals are also observed at some random time point, but with small pieces. So most of the existing prognostic model cannot work with this case B and case C. So I'm trying to address this challenge. Another research topic I've been doing is to build prognostic model for multi-sensor applications. So there are several challenges here. One is sensor selection. That means since a system is monitored by too many sensors, probably not all of the sensors are important. So how to select which sensors are important for prognostics? So this is the sensor selection problem. The second challenge is how to fuse the signal from multiple sensors to build the prognostic models. And since there are, after selection, maybe also there are many sensors, and the signal from each sensor will be high dimensional. So there will be computational challenges. So I'm also trying to solve the computational challenges for the multiple sensor systems. The third topic I'm working on now is prognostic model for image-based degree signals. So what is the image-based derivation? That's, for example, for bearing, we can use monitor the condition of bearing use an infrared camera. So each time you can take an infrared image of the bearing. So the challenge here is since the image will be observed over time, so it's a sequential image. So there will be complicated spatial temporal features need to handle, and also the image is high dimensional. So we need to address the computational challenges. That's all. Thank you.
Good morning, everyone. My name is Wei Chen. I'm from the Department of Industrial and Engineering. from University of South Florida. My advisor is Dr. Hui Yang. Here is my research roadmap. Because reference is one of the most common phenomena of complex systems, such as the ultra-precision machining and cardiovascular systems. Therefore, my research topics focus on mining dynamic references of complex systems in 4 directions. That is feature extraction, monitoring and control, modeling and prediction, simulation and optimization. I have published 1 to 2 papers in each of these directions. During my PhD study, I have achieved several honors and awards. For example, I received the Graduate Student Research Training Grant from the University of South Florida, the Student Scholarship from the IMS and ASA Spring Research Conference, Best Student Paper from the IEEE CASE Conference, Best Student Paper Finalist, NSF Travel Grant, Best Paper Award from the IIE Annual Conference. This photo is taken for the Best Paper Award at the IIE Annual Conference. I also participate in several service activities. I'm the second chair of IIE Annual Conference, the organizer of Simulation Lab in USF Annual Engineering Expo since 2011. I'm the coordinator of the USF Table Tennis Club. I also volunteered in the NSF Career Proposal Writing Workshop and reviewed several conference proceedings and journals, such as the IEEE CASE Conference, IEEE Transactions on Automation Science and Engineering, IEEE Journal of Biomedical and Health Informatics. The left figure is taken from my postdoc presentation at USF Engineering Research Day, and the right photo shows that I'm taking care of the simulation lab during the expo. Finally, I would like to thank the University of South Florida and the U.S. National Science Foundation for supporting my PhD study. Thank you.
Hello, I'm Hong Go, a PhD candidate in Industrial and Systems Engineering at Texas A&M University. My research interests includes several fields, but let me describe that by introducing my ongoing researches regarding wind energy application. Wind energy will serve as a major power source in the future. For example, U.S. Department of Energy envisioned a goal of 35% wind energy penetration in U.S. by 2050. However, there is a fundamental challenge in practice while achieving this goal. That is, the source of the power, the wind, is uncontrollable, which implies that sustaining the level of power supply cannot be achieved simply by controlling the input for the production. The best thing we can do is to control and improve operational efficiency of wind turbines. That is to improve the level of power production for given wind resources. Meanwhile, the effective control of the operational efficiency begins with accurate quantification of the efficiency. To quantify the efficiency, we need to know the efficient performance, representing 100% efficiency, and this will serve as a benchmark performance for the efficiency calculation. However, the existing method in the literature, as well as the industry standards, cannot define the benchmark performance for operating wind turbine. So we brought some ideas from production economics, where the estimation of such benchmark is one of the main focuses. Based on that, we developed an estimator representing the benchmark performance for operating wind turbines. For its actual application, we use some tools in statistics and machine learning to obtain more sensible region. Then these all together will provide better understanding of operation of wind turbines and will facilitate the control of the power supply. Thank you.
Good morning. I'm Chen Kan from Penn State. My advisor is Dr. Hui Yang. My research focuses on the monitoring, modeling, and analysis of manufacturing systems and biological systems. For monitoring, I designed the portable sensors with various modules that can measure the EKG signals from the patient. I also designed the smartphone applications in Android and iPhone for doctors to view the signals. For modeling and analysis, I designed some new methods, including the spatial-temporal mapping for the health informatics and network monitoring for the process control. One of the papers was the feature article in National Journal of Biomedical and Health Informatics, and I received an award from ICI's mobile competition with my partner, Dr. Dong Hongdu. And I also received an award from Florida Healthcare Innovation Competition, and I also was the entrepreneurial lead in the NSF ICOP chief with Dr. Beya, Dr. Sanjay Castro, and Dr. Dong Hongdu. For teaching and service, I was instructor in USF for one course for 2 semesters, and I helped organize the USF Engineering Expo for 5 years. And I also did a job in the USF INFORMS chapter. In this summer, I was working in the Museum of Industry, Science and Industry to help the kids to learn better about engineering and my research. In addition, I was second chair for conferences, including the IE conference, INFORMS, and INFORMS Healthcare. In the end, I will thank NSF to support my research. Thank you.
Hello everyone, I am Ra'ed. I recently graduated from the American University of Beirut in Lebanon, and not sure if everyone knows this country. So my undergrad was in civil engineering and with a minor in mathematics. Then I decided to come here at UW Madison. This is my second year as a PhD student with my advisor, Professor Chiu Jo. My research focuses on 2 aspects. One aspect is the reliability, which was my first year project, which is remaining useful life prediction when you have an imbalanced data set. Because most of the times, premature failure has become extremely rare. And currently I'm working on 2 other projects. One of them is survival analysis for prediction. The other one is using some non-parametric methods to model manufacturing systems. I didn't really, this is my presentation, thank you.
Hello everyone, my name is Xin Yu. I'm from Florida State University. This is second year of my PhD study, and I'm a advisor to Dr. Hu. And also in real life, often dealing with some MP hard problems, but I'm an optimistic person, and I like this line. Every problem has solutions from a great movie or small problem. Okay. So the problem I'm working on is about the functional data analysis to understand the dynamic evolution of the nanoparticle structure. So the most common way to analyze the nanoparticle structure is by the microscopic images. However, the microscopic image is expensive and it usually takes a lot of time to prepare the samples for the evaluation. So as a complementary technique, we are interested in some functional signal to infer the nanostructures. 2 examples of such functional signals. One is dynamic scattering data,
and the other one is small angle X-ray scattering data. However, over the past decade, the development of the data analysis method for this scattering data is kind of stopped. Current methods have many practical limitations, and recently we have proposed a new methodology to reformulate this problem because essentially it is an ear-closed inversion problem. So we proposed a new methodology to reformulate it as a problem of support recovery, a sparse support recovery under the high-dimensional regression problem. And we have got satisfactory results and outperforms the current methods. So, but in this process, we also found out that we are facing a serious issue of a high degree of collinearity. It is a common issue for the high-dimensional data. So this further motivates us to develop a new model selection algorithm that could have robust performance against the collinearity. And I will give a detailed description at the session on Wednesday. The time is from 11 to 12:30. And actually, it's not a very good time, it's much long. And but I will appreciate very much if you feel interested and come to this. Thank you.
Morning, everybody. This is Marian. I'm 50 years PhD candidate at the University of Arizona. My advisor is Dr. Haitao Liao. So the idea of my research is that there is a major trend in industry that the manufacturer, instead of selling the equipment, they sell the product to the customer. The motivation to do that is that after the lease period or the service time is done, the equipment is the property of the manufacturer, so they can reuse or remanufacture the parts of the equipment in their new design. The motivation for the user is actually that instead of paying the whole price of the oil and gas equipment or the mining equipment, aviation equipment, they just pay annual or monthly fees for using the service. What they have done is that they have seen this problem from the perspective of the maintenance and reliability. What they do is that they have 5-year failure data of the tires and the motors of the haul trucks in a mine company in Chile. And also they have the angiograph equipment in Brazil. What they do is that we see how the usage rate of the customer affects on the failure rate of the manufacturer. So in addition to the data analysis, we go through the decision making and game theory, that when they want to sign a contract, what is the optimal lease period or the usage rate for the user, and what is the optimal maintenance policy for the manufacturer. We see how different decision-making policies shrinks or expand the feasible region. What we want to extend the work is that we have seen that there is a big data set on the maintenance of the highways in California, that maintenance of the road is never considered before, and the failure rate of the tires. So we would like to expand it in the field of transportation and also renewable energy.
Hi everyone, my name is Yu Zhu. I'm from University of Arizona. I will be graduated in December 15, and my advisor is Dr. Haitao Liao. My research is focused on mainly 3 areas. The first area is the reliability analysis of systems containing multifunctional components. As we know nowadays, as technologies advance, more and more components have multiple functions. For example, consider iPhones, simulator systems, and also smart vehicle radar systems. So, to the best of my knowledge, this research is the first attempt to make reliability analysis on such multifunctional components. The second direction of my research is the probabilistic network optimization. in the frame of random graphs. So the main two topics that I studied on P and DSP, which is probabilistic minimum dominating set problems, and PC and DSP, which is the probabilistic connected minimum dominating set problems. And it is worth mentioning that I also got a recurrent formula for the probability of connectivity of a complete k-partite random graph. This is one of the best solutions since 1959 in terms of probabilistic connectivity. And the third direction of my research is on data analytics on applications of face-up distributions, where an automated model selection method and an efficient EMSQP algorithm were proposed. And to the best of my knowledge, this is also the first attempt to try to find the simplest general face-type structure with adequate goodness of fit. Thank you.
Hello everyone, my name is Xiaowei Yue and I'm from Georgia Tech. I'm a third-year PhD student here. My advisor is Dr. Jian Shi. My background is I got my bachelor's degree in Beijing Institute of Technology in 2011 and got my master's degree in Tsinghua University in 2013. My research interests are focused on strategic modeling, monitoring, and control of advanced manufacturing process. Currently, I focus on three application areas, including the process control and reliability reduction for nano manufacturing scale-up. There's a poster show some technique to do the denoising for deployment signals. And the second area is the quality improvement in multi-stage manufacturing process of composite material assembly. It's work funded by Boeing company. We try to develop some statistical models. Basically, it's a third model-based control to realize not only the statistical process control, but only the in-process quality improvement. The last one is the variation analysis and process control in additive manufacturing, especially the aerosol jet printing process. Thank you.
Hello everyone, my name is Guo Song and I come from the Hong Kong University of Science and Technology. My supervisor is Richard Zhou. Here's my research interest. The motivation is come from the nowadays people tend to share opinions on the e-commerce shopping website. The left is some kind of review, customer reviews. And the motivation is monitor the product review to benefit both the customers and manufacturers. And however, there are some flipped reviews on the right side. The flipped review is defined as you just think the product is very good and leave a positive comment about the customer review. But however, somehow the customers just rate very relatively low on this product. So my approach is to take two steps. First, you need to quantify the review content because it's kind of string data, not numeric, so you cannot put any analysis on the string data. So first step, you quantify the review content as use some kind of text mining technology. Then you will propose an iterative thresholding algorithm based on the just regression to identify those kind of flipped reviews. So the review quantification is composed of two steps. The first is the mining process, and second is the remining process, which will improve the text mining performance. And for the just regression model, I just add additional part, the gamma, the term to identify whether it's flipped or not. So if the gamma is non-zero, that means this value is flipped. So we need to impose some sparsity on this gamma term. So I impose the iterative thresholding procedure to shift this object. Thank you.
Hi, my name is Jumbo. This is my second time participating in this session. What I learned from last year is no one remembers your name. There are too many students, so I don't want that happen for me. My name is Jumbo. You can imagine a rainbow in June, so it's Junbo. Please remember my name. So I'm a PhD candidate at University of Wisconsin-Madison. What I do is hard to explain what I do in such a short time, but you also can remember the smart and connected system is my primary research interest. It could be a smart teleservice system where you collect a bunch of data from the car's own road using the cloud, satellite, and do the data analytics in the back office and send out some alert. Also, you can think about the smart and connected healthcare system. Especially, I'm working on a chronic disease management, specifically asthma. When people use rescue inhaler, we record the time and location of each and every use from that specific patient, and we do data analytics to send out some meaningful clinical alert to the patients, and we can do some therapeutic decision making accordingly. And also, the smart manufacturing, the cloud-enabled data management platform enable us to make the manufacturing so-called smart. So that's another area that I'm interested in. I use all kinds of possible statistical engineering and mathematics to do three things. One is diagnosis. I want to understand what's happening right now. The other one is predictive analytics. I want to know what will happen if I do this at this moment. And combine them together, what I want to do is data-driven decision making to make the connected system transform to a smart and connected system. Thank you.
The next student is Abdullah Shahad. Abdullah is in another session, so he cannot be here. I will introduce on his behalf. Mr. Abdullah Shahad got his master from mechanical engineering and statistics. He is currently a PhD student in the University of Wisconsin-Madison. The supervisor is portfolio. Actually, Abdullah has a poster in the back, the first one. So he's working on topics including data mining and fusion modeling based on real-time system monitoring for degradation analysis. The poster there shows actually how to integrate multiple sources of signal to generate a quality index for health monitoring. And he also works on data mining, smart monitoring for healthcare systems, and dynamic statistical modeling, smart modeling for dairy farms. Sobambo Sonina also in next door. You're here. Great.
Thank you.
So hi everyone. My name is full name is Shabamba, but also like Jumbo, you can remember me just by thinking of Bamba. It's like a Rambo with a B, so that works well. I'm in my final year now. I've been working with Professor Dasgupta, and I'm on the job market. So in the time I've been working with him, I've had the privilege to also teach a few courses, mostly more like application of statistics to several fields, economics and business, financial statistics. And then I've also done time series and prediction teaching job. My research interest, pretty much the design of computer experiments. I've also been working on optimal design of experiments, especially within the industrial engineering field, material science applications. I'm highly interested in spatial temporal statistics. And then I've also been thinking about how you model geometric shapes, the sort of you see in a 3D printed objects, and things like graphene, flakes, and so on. Recently, also, I've been working in adaptive learning in massive open online courses, where the sort of goal is to personalize the treatment you give each person. You don't want to expose everyone to the same kind of learning opportunities.
So, yeah. So some projects I'm still working on, they're still open. A few of them are missing data formulation for understanding the formation in three-dimensional printed objects. It's something we are still working on. I also came up with a Bayesian lasso Gaussian process model for sort of showing what graphene flakes would look like when you try to produce them in the lab. I'm still working on adaptive learning, specifically in Harvard's and MIT's open online course called edX. And there are also going to be extensions of that to personalized treatment, even in medicine, in other fields. And also one recent thing I've been working on also is just the optimization and design when your covariates are noisy. So when you have that noisy internal noise going on, how do you say anything about optimizing? How do you design future experiments? Yeah, so these are my sort of publications and submissions that I've been working on. Thank you.
So we have finished our student part. So next we honor to have Professor Shi and Professor Das here. So please, we invite Professor and Professor Das each give a short comment first, and then students have ask any question. Okay.
Okay. Well, this is a very wonderfully arranged session. I've learned so much about upcoming graduates, and congratulations to the organizers. They have really done a great job. Do you agree? They've put together a brochure. That's just, I like, what is this? Very good job. So I'm glad to be here. I'll let Dr. James introduce himself, and then we'll be happy to answer some questions, right? To the best of our knowledge.
Yeah, just a few words. First, thanks for Taibo Wang and Huyan for put this session together. Put a lot of efforts, as you can see, with your correspondence, and also try to raise funding to have a lunch so we can hang out longer with students. And the original idea to have this one is try to create a community. In the past, students come to the INFORMS conference, sit in different sessions, and go out without chance to introduce themselves, and also now to create something like a community. I think the best part for this one, in my opinion, is the student can give a presentation briefly and put this one in the first day of the INFORMS. So you can know each other, hang out each other, and for long term, this can create a community. And really, the QSR, called this Strategic Liability Filter, is from the students, no matter go to academia or industry. And as you make more friends here, there's also retention after 5 years, 10 years, you still come back, hopefully, and mentor new students, new PhDs in the future. And also, very excited to see some not only finishing PhD students come here, give a presentation. I see a few faces try to hire people, so that's a good thing. And also, students from second year come here. That's like 3-4 years to go, and over time you can make friends with junior faculty, senior faculty, your fellow students, and create a community. That's the objective, one of the objectives. I think that's all I'd like to say. If you have any questions to ask me or any other people sitting down here, we can talk.
Those who are in second year, can they come again? You're allowed to come only once, or what's the deal? Because I really like that too, that instead of waiting for that, right before your graduation, if you can introduce yourself ahead of time, then it gives you time to build more friends and community. It's really helpful.
So we go back, talk to fellow brothers, sisters, and academic brothers, sisters, and let them listen next year. Especially some foreign international students, we hope to see more.
Generally related to quality statistics and it can be quality control, data analytics, data science, reliability, and
we invite Professor Dawson question, not just the senior. So if you look at Professor Dawson's homepage, he has really thought a lot about student education and also implementing his idea, his philosophy in leading a department. And also perhaps one of the most, I would say,
successful?
Yes, successful
students.
Students. So that's why I also learned here. So any questions like your graduation and job, research, feel free to ask.
So I'm in a job market.
The rainbow?
Yes.
Okay. All right, go ahead.
So I have been thinking a lot about where I would end up being. I'm mostly looking for an academic job, and I know it sounds a little weird, but if you get an offer from 2 universities, and one, I see a lot of QSR family already there, the other, 0 QSR members, then what should I do? I mean, which university? Of course, I can do more collaboration. If I go here, I'll be unique. So, if I'm in that position, do you have any advice for me to do? Of course, I'm not saying that I will get a 2 job.
Well, maybe you get more than 2. The rainbow can extend across the country, and many people will be interested. I'm sure Dr. Shi will have good comments to add. I'll just add it. In fact, I was just having a similar conversation with someone that there are 2 types of at least 2 types of workplaces, and your observation is absolutely correct. In some places where you could be, you are in an area where you are perhaps the only one working in that area, so you don't have any internal competitor. Whereas you could be in another situation, and you said that already, I'm just rephrasing what you said, that there could be 3 other professors doing the same thing, or similar things, not the same thing. So you have an internal competition, right? So there are benefits, of course, you have more collaborators, that you don't have to see them only as competitors, even though they could be, but they are great collaborators too, right? So as a young professor, you get to collaborate with them, bring your ideas, and that's a great benefit to obtain from them. But being your own, being the only person, that has great benefit too. And then I'll tell you that in the University of South Florida, it would be an example of where you could be, because of small faculty, could be the one and only one in that specific area. Whereas if you're at Georgia Tech, it could be the other situation where you are with 3 other people that are doing similar things that you can collaborate and work with and compete. And sometimes, okay? So,
I think that's a good situation in more choice. I think go to which place to go. To a number of faculty members and QS are related. Such one factor is not the main factors. The main factor is where you want to go. You can many factors about research program. Some people collaborate in or not in QSR or outside QSR faculty members, and also depending on types of research. If you need certain type of industry, you can either close or strong link to the department, to the schools and everything. And to do something related to healthcare related research. If there are hospital nearby, they have a good relationship, or they already have a very bad relationship.
So how can I know whether they have a bad relationship?
No, you can see do they have a collaboration already, and who have been collaborated, like in Michigan, I was there for many years. There are medical school, there are engineering school, has a good relationship, ongoing research activity. Same thing in USF, I know you have very close relationship with healthcare part. So you can see there are many activities, and also if they do have a healthcare hospital or something with no activity, then also indicate something either wrong or something needs to be developed. I mean, being alone and or joining a group is also dependent on person's personality. Some people is a potential leader, and some personality is very aggressive and in research such way. Some people also excellent in research, more like the others, more like a doer rather than a leader. It's okay, also good factor. In this situation, join a group is better. Another thing I like to say is for faculty, for department try to hire someone, you are not duplicating them. things like here. I mean, even they have a colleague reliability statistics in the school, they are not you. I mean, if you are overlapping with someone very strongly, you are not given over.
That's a very good point. And also, if I just add that when you interview, then if you have a thought that might be the case, that there are other people who are doing similar things, and absolutely correct, as Dr. Shi said, that department is unlikely to give you an offer if there is a very strong overlap with another person. But if you suspect that might be the case, then ask questions. When you interview, it's not just the department trying to find out how good you are. We're trying to find the same thing about the department. Is it the right place to work? Okay, so don't feel free to ask as many questions as you have, and ask those kind of pointed questions to the chair. Not limited to chair, but he or she is a good person to ask that question. I see that there are other faculty who have similar interest. What do you think about how it's might impact my ability to do what I want to do? Can you shed some light on it? When you're meeting with the chair, or you can ask that to some senior faculty too, who probably not in the area, but in other areas. You could ask the senior faculty the same question, so you'll get a good sense before you finish your interview with the university whether this is going to be a good thing for you or not. So I would say that ask as many questions. While answering their questions, you have your questions too. And universities like that. They figure out that this guy is really thinking, long term, and how to. So I'll stop there.
What do you think about INFORMS? Can they help?
INFORMS interviews?
Once again, I think the process for INFORMS interview, there are two types of. Normally, before the INFORMS conference, the search committee work very hard to identify shortlist. And then once they have shortlist, we hope people say, and then some people who say, this person is on the shortlist, here the CV, we want to see them, provide feedback. So this one type of interview. So you should be very prepared. Just like for me interview, to be impressed. These two people also ask, if this school is ready to go, who else is here? Come here, someone who should be careful to talk with the faculty members from the school, come here from the school. So that's one type of. Another one is there are some tables somewhere. So you can go there, have your CV. And I think this one definitely not final, but this can be interview and leading to two outcomes. One is say, after interview, not so impressive. Okay? Another one, after interview, I think it's very good. And then this person can change in the department for you. And then some department leading to performance. So pay attention to this. And also, if you are on the market, certain school you like to go, be good. Try to study the program or some other senior faculties from there, even not in our areas as a non-course. Not just see the QSR, not just faculty member in QSR, we try to see some other people discuss, and also think about how you make libraries with people not in QSR. Then establish that in a certain way, develop a bridge.
If somebody misses some of those interviews,
if you are scheduled interview, you is not a problem.
No, missing deadline. Missing the deadline for submission of
I would say that I want to say if you submit proposal application before INFORMS, that's a great advantage. If not, definitely not a loss. It is a certain disadvantage.
We routinely many universities, they always want to meet as many candidates as they can while they're here. I can speak for our university. We've done that. Dr. Hui Yan last year spent like many hours meeting with many of our candidates that we were looking at last year. So it's a good thing. So.
looking for a postdoc.
talking about if you're applying for a postdoc position.
Yeah.
So, James, you have many postdocs, so you want to answer that?
I'll say the first one to a postdoc first. Yeah, I'm evaluating chances. I specifically talk about myself. I have 15 years work experience, and I evaluate the experience in the work, bring products or securities of vehicles in the street, everywhere. Or maybe this time of the doctor, my PhD work, maybe I have originally two papers, and maybe they don't show exactly what I do. So, how do you evaluate?
I just know. First, I think in IE, Industrial Engineering Department, postdoc is not required, even from like chemistry, bio, social, must postdoc for a year. So IE is not. I think the number one criteria for IE, just I think you are able to write public papers. You are able to demonstrate you can do it. Another thing, the research topic, leading potential funding. In some research, you think very important for your work, and potentially you cannot see what the proposal. Because may not be the best. Sorry to say this, but the engineers. I think another thing is working experience is a plus. On top of you have top papers, you are able to write it, and you are the first author, third or fourth author. Some other people write paper, but you are very capable to explain the problem, many things. That's enough that you are able to write it. You are able to write it. Again, working experience more mature. So that's
many of the students are more interested in job hunting this phase. Actually, we also see some second-year students. They're passionate about curriculum. I know, like in geotech, they have a systematic informatics track with well-designed curriculum. But for QSR students, maybe many you already had confusion in the very beginning, like shall we learn some OR courses, shall we also learn like compact courses? Those are all from high level. So for us, very early how to design the curriculum or if any suggestions for student students.
That's very good. That's a very good question. And that could be a dilemma for the first year. I think first year student really, that should be something in mind of the first year PhD student. Because by the second year, you've taken most of your classes already. In the third year, you're pretty much on a, generally, right? I mean, on a research track. So as you get in the PhD program, of course, that doesn't really apply here. All of you are either in second, third, or fourth year of your PhD program. But it's a good discussion just because you'd be advising students soon, right? Or someone could be asking you that same question too. So selecting, once you have an interest, research interest, I think that should really guide the course work selection. And you're right that you just don't want to take, a bunch of courses without thinking, what is my area of interest in research and what courses will help that area of research. And that determination needs to be made early on so that you're not wasting any credit hours. It's not waste, really. That'd be wrong to say. If you have taken a course in human factors and your work is in, data analytics, has it been a waste? Not really, because it really helps your portfolio. Maybe you'll find something interest in data analytics and human factors. There is a human factors faculty who's doing some modeling that you can collaborate. And because you have taken that class while you are a PhD student, now you said that I can use that, and that sounds like an interesting. So nothing really goes waste. It always comes back to benefit you in some way or the other. And that has been my experience, and I'm sure many of you have the same experience too. But yes, it is a good idea to really talk with the major professor. This is what I want to do. So what are the courses that I should be, doing, and make a plan as soon as possible in the PhD program and follow that track actively, as opposed to sort of, taking a bunch of classes and see, what's going to be beneficial or not. And I just wanted to add something that Dr. Shi said that, he said he's sorry that engineering is, but I don't think he's sorry because without grant, you're not going to go anywhere as engineering professor. And when you become an engineering professor, you are a small business owner. Really, seriously, you are a small business owner. You have your own business. You are your own empire. You get grants, you get funding, you bring students, you build your team. That team is your responsibility. So yeah, it's a business. Engineering professor is being in business. So you have to think about where the grants are going to come from, what topic is going to be. So you can't do anything about it.
With French and take more courses. And that's in my experience. For my PhD students, if a PhD student from mechanical, I brought one from mechanical engineering who also graduated engineering, so I got a PhD student from there. So for a PhD student from mechanical, normally I strongly encourage them to get a second PhD and also master in industrial engineering or OEE of computer science. So these are like 5 years and 4 years study after qualifying exam, which is the first year. They can take some courses in an organized way and then get another degree. I think that's helps not only for research but also packaging. If a student from industrial engineering PhD, we encourage the guy to get a master in statistics, computer science. So in this way, they are our research, academic research system in China. So you have systems, you have certain things get a PhD, and also you get a 2 base in statistics of computer science, which can make this and also all our courses very good, very, very important. I think we means the QSR person may not make original conclusions in operational research or statistics, but have some fundamental training, learn those tools, and come back, cover our research, and go deeper than normally we can do in such a class. That's a big question. The question is writing proposal different from writing papers. Any tips for writing proposal? I think big question. I try to answer it short. Okay. I think first you should have a very clear motivation. So the motivation is a real problem, real national need. Not something you're interested in. Real need or national fundamentals of the motivation. And then you say, under this motivation, what has been done, and by others. And then you say, and then you summarize what by others done cannot address that kind of motivation. There's a gap. And then from this gap, you want to fill in this gap as objective. And then here's my innovative ideas. And what are truly innovative, so there are 3 of innovative. I think those are the most important things. And then after this, you have a proposed research tasks. The research task should be logical. I don't want to say it's not important, but the less important than what I said before. And then depending on the research tasks. And if you talk the research tasks, when you talk the ideas, you give an overview of your proposed methodology. That's also important. So people should understand the overview of a good picture, what you like to do, and then propose tasks. I say 2 tasks are too little, 4 tasks are too many, so 3 tasks. And then when I said you have some innovative ideas, application, carbon energy or some other things, you have some biotechnology and market to other areas, how to generate impact, the path to generate impact. I can say
that's a fun proposal already. Follow that track, you got fun.
Sorry, one more thing. After the proposed task, you you are the right person to do it, and why you can do it.
My question is that because grant is one of the most important part for you to select new faculty. So how can we show our potential to get the money in our CV or during the interview?
Well, I mean, I can say everything now, honestly. You accomplish that during the interview. Okay? If you have given good thought to, one question that most schools will ask you, that what topic have you decided on the topic that you're going to write your career proposal, right? And I do. I ask that question. Okay? So, and then I see how the candidate is able to articulate a sort of a vision for. And you don't have to have an idea all framed and everything at that point, because most people don't write their career proposal in their first year. Okay, and then so because you have time to really frame that, but to show that you are thinking along that line, okay, and you have an idea that you are sort of, you're building on that. So that's a good way to convince that you are where you're going to submit proposals, what are the funding agents. You have a good knowledge of that, which most those who are here, I would assume that all of you have a very good sense of what the funding agencies are, where you're going to go get your funding or request funding. So those are the kinds of things that I think the department wants to see, that you have a clear plan sort of in your mind. Okay?
I think when you study for PhD, you should do the following thing. It's not a good PhD, it's graduate. You should be able to define the problem, identify the problem, formulate the problem. From the problem, you know how to do it, generate original ideas, and write excellent papers. So a similar process has to be developed in undergraduate proposals and business process. When you work on your research topic, most of the time, the topic work with a writer, there are probably two situations. One is the funded projects, the RA, and then the funded ones must be some market money. So if you talk to your advisor, get a proposal study, why this one proposal. So you understand how they write proposal to get funded. And another situation is your advisor has certain vision on try out certain things. So you work on this one, and your advisor will write the proposal. So in this situation, you're acting physically tied with your advisor to write the proposal, go through the process and see how your advisor organizes problems and things. And like some said, you should know the funding agencies for your general research topics, who will fund you. From the SF for sure, from the energy, DOE, NIST, whatever funding agencies. And also you should say more specific what kind of program, not just say from the agencies you want to together. And also always pay attention on corporate proposal. I ask my students to pay attention on the EAA. BAA basically that's a corporate proposal for companies building programs. You see something, even if you don't write a proposal, you see what are the hot topics and how your idea can be formulated. And then by the time, they will ask you what your career proposal topic. So you should have certain topic in mind for you. And also they ask you what do you where you write funding, where you write proposal, who you funding. You can give a list, say for example, advanced manufacturing, they emphasize in situ sensing. It's very important, right? The corporate proposal and also there's something certain things. Yeah, fast. I'm working on this. You might certain proposal structure. I think we all know.
You could even go one step further. See, you could go to NSF website and see who the recent fundees are, grantees are, right? So what topics they have been funding. And if you can talk about that while you're interviewing, that I was looking at NSF site and see who they funded recently, and saw that they are funding this area, this is an interest area for NSF, or whatever the funding agency might be. So if you can talk about those kind of things, then you have really demonstrated that you are deep into this process, okay? And you have spent some time. Those who are early in your PhD program, as Dr. Shi said, that you should definitely ask your individual professor that if you could engage with him or her in writing proposals, okay? But not all mentors are the same. You know, some major professors routinely engage their PhD students in writing proposals, but some don't. Okay, but you should insist. You should ask. You know, can I engage in the next proposal that you write? How can I help you? How can I engage with you? Can I write parts of it? You'll do it. You know, many of you have probably done it anyways, but you should insist on that.
Real question about proposals. First is we submit proposal to different agencies, like ISF, industry, or DOE. So in writing, what's the difference in preparing? The second question is, so when we submit our tenure package in a few years, so how do you evaluate funding proposals from different agencies, like industry or ISF? Or just it doesn't matter as long as it's money. So the third question is it's also about promotion. So collaboration is definitely important. So I may have fund projects like SCPI or PI. So how do you score them individually?
I would say one question.
You have 3 questions. First, remember 3 questions, right?
Yeah. I think for the tenure promotion, that's the last one. How to make the collaboration and funding situation. I think every university have different way of approaching. In Michigan, I was actually in Michigan when I was Georgia Tech. I can see it's in Michigan, you should have sole chair students graduate. In 81, one is okay. But if no graduation is problem. And funding-wise, you should have a single PI also, and also collaborate. Collaborate is also counted, but you always collaborate. I don't think that anybody can do it. It's very impossible. In some school, you have with faculty casually, they may say you need whatever number, something else. But officially, I think you should demonstrate you can get funding from NSF. I mean, career is best, not career regular NSF. You should have NSF. You should have funding from industry or government. That's considered one up. So this one is important that students' papers, top journal papers. Too many second-class journal papers is negative. Too many is negative, not say not class. Yes. What's the second question?
And the first one is about
difference between proposal writing, the DOE and NSF. Different.
Other than topics, I know they focus on different topics, in writing.
In writing, definitely. I mean, in SF, they emphasize on fundamental research, education, those kind of things. For any other government agency, who is the funding agency, they come with their particular interest. I mean, and also depending on the funding scale, they call it like relevant fundamental, immediate, and the implementation. So you have to know the funding agency with public proposal very carefully many times, and public program director, and then try to follow other faculty members, collaborators, or friends, if they can share their winning proposal with you. I think that's the best thing. And then follow the structure of the program.
Well, those two are really different writing styles, NSF and other funding agencies. So it's a very good question that you're thinking about those things. Can you come to
Same thing. I'm thinking about call advisor. I said even culture. In Georgia Tech, co-advisor is considered as a single advisor. It surprised me. So I can, like a single advisor, you can co-advise students all the time, and they still get tenure. This is not the case in Michigan. But in Georgia Tech, the fact number not me, very proud of this. We encourage collaborator, so I think it's okay here. So I in Georgia Tech. And I joined this culture, so I told them I said it's a good culture.
So sometimes I've seen that, not very often, but sometimes some young professors would getting invited by others because you bring strong skills in an area, and immediately others in the department, outside the department, in the university, recognize that this person has strong skills in this area, and they start inviting you to work with them, and you get very busy doing those things. While it is good to be invited and be part of other teams, as you heard from Dr. Shi, that you have to be the leader too. Just as they invited you to work with them, you have to invite others to come and join your team too. So you can show that while you're a good team player, you're also a leader. You can lead your own projects. So I've seen some cases where people get too busy doing, working for others, and they become sort of hired hands. Not exactly true, but it kind of sort of feels that way. Yeah.
This one said, if you have like unit one in research, don't make more than half collaborative efforts. So you have your own independent things, and then you also collaborate on others. And you cannot get rid of independent things. Even assume you join faculty in Georgia Tech, I say the same thing. I said, unless you want to stay here forever, if you want to jump to Michigan to co-advise all the time, you cannot get over Michigan. Just have to exam. So you should be able to demonstrate yourself, independent researcher, independent mentor, advisor, and the PI. And then you work with others. Unless this is like a norm.
Though I'm not a student, but I would love to get your insight on the soft skills to young professors and junior faculty. I've talked about a lot of hard skills, but we're looking to what makes a department chair mad, might be brilliant, to some sort of soft skills you can get some idea from the
Very good question.
You're the top chair.
You have seen just as many, that soft skills very important, very important. While your technical strength, your ability to write, your ability to do research are critically important. Your ability to work with others in the faculty is absolutely critical. Your contributions as a member of the team, your ability to really show that you're part of the team is very, very important. Okay, I was just telling someone this morning that just speaking on Hui, because I have the right to speak on him, right? so I was just telling someone this morning that every time I ask something from faculty, Hui always, even though he was extremely busy, okay, he was the first one to respond. Almost never failed to do that. But that's part of the soft skills too. What it means that you have placed an importance on that matter. That I have to do the same thing. I have to submit this thing or do this thing anyways. I can do it 3 days later, 5 days later, and have the chair or whoever is asking for the information send me 2 reminders, or I can do it today and get done. So that's a great strategy, So that's part of the soft skill I consider, And when you're put in the team, committee members in the team, don't give the feeling to the other members that you're too busy with your research and hence you are late or you can't do this. Okay, the busy people get things done faster than those who are not busy to begin with. So that's also part of the that you place an importance on that issue. So it's very important to be known outside the department, to to make you yourself known, and not just, that's part of the soft skills too, so that other faculty members in other departments, they recognize you, who you are, what you do, because you stop by and talk to them in the corridor. When their student asked you to be serving in their committee, you didn't say that I'm too busy to do that. You said, sure, I can do that. So that's how, and I've just addressed some of the soft skills, but we have some more.
I'm sure. So I think the most important thing is communication skills. So you can talk your ideas very clearly and logically, and also you are able to talk your ideas 1 minute, 5 minutes, 30 minutes, 2 hours. So depending on the time available with the audience. And also you talk to the audience, private person, in the right language. So you can talk to a domain expert. That's very well, one language. For social, and you talk with all person on your research. The right person with the right language. Same thing to the company people, CEO, brand manager, shop manager, non-workers. You can communicate. I think that's a very important soft skill. Another thing, work with people. Always respect whoever you work with. Do what you committed, and do more than you committed. I think that's very important. And by the time cut the cake, give other people more, you get less. If 50% is very reasonable, ask for no more than 45%. And keep doing this way. And then there's the room in between graduation and there's more room to go. If everybody asks 55%, that's a problem. So be humble, that's my be humble, respect others, and committed. Also be careful to determine who you work with. We are human beings. Some people get along very well, some people may not get along. You want to get a new place, talk with people quietly, politely, settle to find out certain things to avoid, certain things to avoid.
One thing that they say in leadership, they say, create a lot of good and just give it away. Okay, that's the goal. That's something that they say. And that's exactly what you heard. When you cut a cake, cut a bigger piece for others. Okay, first of all, make the cake. Make the cake and give most of it away. Leave little for yourself. That's when you're going to be, you're going to be known. Okay. Keep most of it for yourself, not good. So the idea is create a lot of good and give it away as fast as you can. Okay?
One last question. The question can leave more time for lunch. Really appreciate Professor Das because they have moved around their schedule to join this session. Really appreciate that. Thank you.
Once again, I want to say Kaibo and Hui just done a magnificent job getting this done. So I was very, very impressed with what they're doing. Okay, thank you very much.
Not done yet. There's one exercise that during the lunch, actually, we intentionally invited some junior faculties just to ask some questions about how the recruiting committee see the potential or how to evaluate you. But we also invited junior faculties to tell you their experience, how to get a job last year or the year before last year, the new junior faculties. And also we have guests from industry. We may ask them if you want to go to industry, what's important in the interview, and also the work experience there. So Professor Huang is more senior, but he will be here with us. So let me see. We actually ordered lunch for 40. I counted the number of here is still enough. So all please stay here for lunch, and still during lunch you can interact and talk to each other more. Okay. So thank you. We end this part, then start the lunch part. Okay.
小一个解释。